So in the last video, we recently talked about Coulomb's law in two and multiple dimensions, and then also this idea of superposition. And one thing that I want to add to that is just a bit more of a complex example, just to make sure you understand everything behind it. And other than that, this should be a quick video. So let's just imagine that we have, if I can draw some straight axes, I mean that's straight enough. Let's just imagine we have our axis, and of course we have our charge that we're looking at the center. Of course it doesn't have to be at the center, but this just makes it easier. So we're going to call this charge A. And A, of course, she's at 0, 0, and also has a charge of 3 coulombs. Okay, and then we have another charge. This charge is going to be at the point 1, 1, 1, 1, and I'll add a -1 here. And this charge is going to be called B. It's going to have a magnitude of -2 coulombs. And of course, it's going to be at 1, 1. And over here, we're going to have charge D. Charge D also has -2 coulombs of force. And it's centered at, or is at -1, 1. So, before we, and the question is, I should specify the question. The question is force on A. That's what we want to find, the force on A. And so using superposition, we can find this. But the most important thing to do first is consider all the interactions we have happening. Between these two, we're going to see some attraction. Between these two, we're also going to see some attraction because opposite signs. And this way. And between D and B, we are going to see them repel. However, that actually doesn't matter for looking at the force on A at the moment. We only have to consider how A is interacting with the other members close to it. So although technically there's a force on D and a force on B, it doesn't matter. Okay, so finding the force on A in this situation is not as easy as the last example we're looking at, because we have these diagonal sort of forces. They're not directly on the line. But there's no need to worry about that. We can just use sine and cosine to figure out the components of the electric force in both directions. So here we have a point at 1, 1. The inverse tangent of 1 is 45 degrees. So this here is a 45-degree angle. And here we also have a 45-degree angle. And this makes things pretty simple. What we need to do is add up the components in the x direction between these two and in the x direction between these two, and then also add them up in the y direction between both of them. And so we can do that. It's just going to be a bit more math. But let's get to it. So we're going to say the force on A in the direction of, well, let's start with x. I think x is easiest. First of all, you're going to have a positive component of this force. If we look at the component, we're going to have this component that looks like this. That's going to be positive. And to find that, that's going to be the cosine of this force here. And finding this force here is the same, this arrow here is just as easy as what we've been doing. It's just going to be K times QA, and then we're going to do times QB over the distance between them. The distance between them is going to be the square root of 1 squared plus the square root of 1 squared plus 1 squared, which is square root of 2. Okay, So that's the force between them. And then to find this pink part, we're just going to multiply by cosine 45 degrees. So K, QA. And you know what? I don't think we're going to plug in numbers for today just to simplify the process, because it's really the concept that's more important. So then times square root 2 cosine 45 degrees. Then in the opposite direction, we're also going to have a force that's causing it to go this way. And actually, it's going to be the exact same force. It's going to be K, QA, QD with against QA, and then square root of 2 is between them. And you know what? I just made a huge mistake, which is very sad. I forgot to square the denominator. We found this distance between them. This distance between them is square root of 2. However, the Coulomb's law states that this is R should be squared. So really, this is a mistake. This should be 2. This should be 2, as well as this and this. There we go. That is much better. And so if you were to actually work this out, what you would get, and sorry, this will also be cosine times cosine 45. So if you'd like to work this out, go ahead, pause the video, work this out, and see then if you get the same answer as me. So welcome back. The answer should be 0. 0 newtons in the x direction. And at first this might seem weird, but it makes sense. We're seeing that this here is going to be pulling it this way, right? This is going to be pulling it this way. In terms of the x direction, this magnitude of the force and this magnitude of the force are going to be perfectly equal, which is going to result in no movement or no force on the charged particle A in the x direction. Okay, so now if we do the y direction, the force on A in the y direction, and we're going to have, this is going to be, or we'll start again with this side, we're going to have a positive force, right? Going directly up, the component of this force here, and this one on the other side is also going to be positive. So there's absolutely no way that we can get 0 for this second force, because both of them are moving in the positive direction. So this will be K, QA, QB, QB, all over 2. This time we're multiplying it by sine theta, sine 45 degrees, because we're trying to find the other leg of it. Coincidentally, sine 45 degrees and cosine 45 degrees are the exact same thing. Then we'll add on the second term, QD with QA over 2, again, sine 45 degrees. And if you'll do some careful analysis, or by looking at the picture, you'll notice that this term and this term are exactly the same, actually, because you're going to get a force. The components here in the y direction of both sides are exactly the same, because this -2 and this -2 are the same. And so if you work this out, you'll get 2 times this answer. I'll work it out with you. You're going to get 2 times the quantity K. This is going to be 3 times 2 coulombs. This is going to be 6 all over. What are we going to have? This is going to be root 2 root 2. So hopefully if I did my math correctly, you're going to get, and then, so let's say we multiply both sides by root 2, we're going to get 3 root 2 K, and that should be the answer in the y direction. So there we go. We've successfully found the force vector of this value A, or this object A, and here it is. It's not going to have any force on it in the x direction because they cancel out, and it's going to have a little bit of force on it. Actually, this is quite a bit of force on it in the y direction.